The Surface High-Speed Opti Area toolpath is designed for cutting cavity shapes such as this mold here. We'll find that under Toolpath, Surface High Speed, and Opti Area. And I'm prompted to select Drive Surface. The general strategy for high-speed toolpaths are selecting the entire model to machine. So I'll go into Solid Selection mode, turn off Faces, make sure Select Body is turned on, click my entire part, and then End Selection. You'll see I have 91 surfaces selected, which is every face of the model. For containment, I'm going to select the natural chain here. Okay. And then on the first toolpath page here, if I wanted to change my mind and try a different strategy, I could easily click different toolpaths here. But I want Opti Area, and we can see the preview down here of cutting a mold cavity, which is exactly what we have. On the right hand side here, I'm given a quick overview of my geometry. Now for a tool, I'm going to rough this out with a 3/8 end mill, and my feeds and speeds, these are set realistically for this type of toolpath. These may seem pretty high to you, 200 inches a minute at 12,000 RPM, but you're going to see when we go through the parameters of this toolpath why these numbers are realistic and very safe to use. Down to my cut parameters. Now these parameters here are the main driving parameters for this toolpath. It's very important that we pay close attention and get them set correctly. Now first off, our step over. This is the XY distance that the tool steps over between each cutting pass. Now generally for these types of toolpaths, this is set between 10 and 20%. We'll set this to 15 here. And then step down. This is the depth cut. In other words, the Z step. Now since we have such a light radial step over, we can take a very aggressive depth cut and use the entire flute length of the tool. 200% is no problem for this type of toolpath. However, the key to that is having the minimum toolpath radius set properly. Now what this value is, when we click on that, we can see the arc motions here are highlighted. This means that the tool will never be pinched in a corner. Whenever it gets to a corner situation, it's going to cut at least a 75 thousandths corner radius. And the general values are between 20 and 40%. I'm going to keep this a little bit tighter down at 20% so I can get a little bit more material removed in the corners. Now for the Opti portion of this toolpath, we have the step up. So after it takes my 3/4 inch step down, it's going to be stepping up and eliminating the large stair steps. Let's set this to 10%, 37.5 thousandths step up. And now this toolpath is always going to be climb cutting, so there's going to be a lot of repositioning moves. And when it's going to be doing those moves, it's going to be moving through air, and I can set that feed rate increased here. That's the back feed rate. We'll set that to 500 inches a minute, and it's also going to micro lift. It's going to pull up 10 thousandths in Z, just so it's not dragging across the floor of the part or unmachined material. And then I'm going to leave some stock. We'll say 15 thousandths on the walls and 15 on the floor. Now onto my transitions. Now this is how the tool gets into the material. We obviously don't want it to plunge straight in, so it's going to be doing a helix. And I like to set the helix less than the radius of my tool. So my tool is 3/8 of an inch, and 40% of that diameter is times 0.4, enter, 150 thousandths radius. And then the pitch of that helix, I'm going to switch from plunge angle, 2 degrees, because I don't know how much load that tool is actually going to be getting at 2 degrees. Move that to pitch. I want that to take a 50 thousandths depth cut per revolution. Onto my steep shallow page here. I'm going to use the Detect Limits feature, which will analyze the model and eliminate any air cutting moves above the part. On down to my linking parameters. Now there are quite a few different parameters and settings we can adjust in here. However, the key one that we must pay attention to is the retract style here. Right now it's set to minimum vertical retract. This would work just fine. However, a bit more efficient way to do it is going to be use the minimum distance. So the tool will be moving in a XYZ motion while it's repositioning. However, the key is you must have output feed move turned on. If this is off, the machine goes into a rapid motion and we run a great possibility of clipping the top of any of our islands here. So if we keep this in feed move, we're going to get a G01 programmed relocation move. I'm going to leave all the other defaults here because generally those will work just fine. Down to the arc filter page. This is important that we adjust this as well. Now I'm leaving 15 thousandths on the model, so I don't need to machine it any more accurate than that. I'm just going to set the total tolerance to 10 thousandths, go into Refine Toolpath, and then I'm going to turn on my line arc filter settings and make sure I can get arcs in the XY plane. Okay. And then if we roll through a back plot here, you can see the tool nicely helixing in to its full depth, 200% depth cut. And in my back plot here, I have arc motion as orange and linear motion as blue. So my climb cutting action is real nice arc motion, and my repositioning moves are these blue lines here. And if we take a look at the detail analysis here and watch the feed rate in particular. So right now the tool is in a cutting pass, so we're cutting at 200 inches a minute. And then when the tool comes out of the cutting pass and goes for a repositioning move, it goes to 500 inches a minute. And that was our back feed rate value we set. Also, the tool is coming up 10 thousandths, so it's not dragging on the floor. One other nice detail you'll notice is the tool always makes arc motion in the corner. This is our rounding radius. The tool will never go and bury itself in the corner. It will always leave it with a cutting motion. So after it evacuates the majority of the material with the heavy depth cut, it does these step up passes now, smoothing out the walls. Then goes down for another depth cut and works its way back up. Let's take a look at a verify. We can see the cutting action a little bit better. Heavy step down, and then the step up to blend it in.